Welcome back, friends. Let's look into the second form of energy, which is kinetic energy. Now, what is the kinetic energy? It is because of motion of the object. So let's say this is an object which is moving at velocity of 5 meters per second. So I can call it as velocity also. I can call it as speed. If I'm specifying the velocity, I have to specify the direction. But because energy is not a vector quantity, so this direction won't make any effect. So I wanted to find out the object is moving at a speed or a velocity of 5 meters per second. I wanted to find the kinetic energy in the object. So kinetic energy formula is half mv square, and the mass, let's say, is 1 kg. So half times 1 times 5 square, that will be equal to 25 divided by 2, which is 12.5 joules. So that's the simple way we can represent the kinetic energy. Now we will talk about the mechanical energy, which is equal to the sum of these two energies. So there's another form of energy which is called mechanical energy. Mechanical energy. Mechanical energy is sum of potential energy plus kinetic energy. Add of these two. That is mechanical energy. So mechanical energy equal to PE plus KE. Now this formula will be applied to two different kinds of problems. One is for non-isolated system, another is isolated system. First of all, before I start applying this formula, I want to understand what is an isolated and non-isolated system. So let's look into the isolated system. Isolated systems are those systems in which no heat can transfer into the system or can transfer out of the system. So there is a boundary. If let's say this is one system, and this will define as a boundary of that system. So nothing can come in and nothing can go out of the system. Neither heat nor mass, nothing can be transferred. Okay, so that system is called isolated system. I'll take an example. In real world, there is no perfect isolated system which exists in nature. But I'll take an example which is close to the isolated system. Let's talk about a thermos in which you will add up some hot water. So let's say this water is at 100 degrees Celsius in this thermos. So what does thermos do? Thermos try to keep the heat inside this bottle. So right now the heat is 100 degrees Celsius. After 5 seconds, if you're going to measure the temperature, it will still be 100 degrees Celsius. After 5 seconds, shall I write 5 seconds? So for those 5 seconds, we can consider this system as an isolated system. But if I look at the temperature after 24 hours, so I will find that the temperature will go down. So eventually this is not a perfectly isolated system because heat is being transferred from the system over a period of time. But for first 5 seconds or first 10 seconds, it was an isolated system. So we can say thermos is a closest thing to the isolated system. So non-isolated system means then non-isolated system means in which heat and mass can transfer from system to surroundings. So if this is a system and then this becomes surroundings, and then this becomes boundary, and boundary, oops, one second, boundary, this becomes BND, and then this system is being differentiated from surroundings with the help of boundary. In non-isolated system, heat and mass can transfer from here, with respect to heat and mass can be transferred from system to the surroundings. Only if the heat is also getting transferred, still we will call it as non-isolated system. So hopefully you were able to understand the difference between isolated and non-isolated system. In the next video, I will talk about the mechanical energy in detail.